Hello friends, welcome back to our channel. This is another video on interview questions and answer series on clock domain crossing. In our previous video, I asked you one question, and in this video, I'm going to answer you that question only. And now, without wasting much time, let us get started. Friends, in my last video, I asked you one question, and the question was, can a pulse signal be transferred from clock domain A to clock domain B using simple multi-flop data synchronizer as shown in a figure? So here I want to apply a pulse at the clock domain A, and that pulse I want to transfer with the help of multi-flop data synchronizer here. Here some other receiver side logic is there which want to receive this pulse. This was my question, and many of you tried to answer it, but for those who could not understand it, I will reveal it in this video. Friends, the answer of this question is no. We cannot send this pulse from clock domain A to clock domain B with the help of this flop structures. That is called multi-flop data synchronizer. It is not possible to send this pulse from clock domain A to clock domain B. To dig deep into the answer, I will consider three scenarios. In first scenario, we will consider that clock domain A frequency is equal to clock domain B frequency. And in the second scenario, we will consider that clock domain A frequency is greater than clock domain B frequency. And in the last scenario, we will consider that clock domain B frequency is greater than clock domain A frequency. Let us start with the first scenario where clock domain A frequency will be equal to clock domain B frequency. Friends, let us discuss our first case where clock domain A frequency is equal to clock domain B frequency, and let us prove that we cannot send this pulse from clock domain A to clock domain B with the help of multi-flop synchronizer as shown in a figure. To prove this, I have taken this particular timing diagram as clock domain A and clock domain B both are asynchronous to each other, and I have considered a slight phase difference between them, but the clock frequency is same. As we know that we are feeding this pulse signal to flip-flop 1, and on the positive edge of this clock A, we will get the output of this flip-flop 1, and let us name it as FF2 underscore in. So at the output of flip-flop 1, we will get the signal as a pulse. Now just assume that clock A and clock B has a very small phase difference, and FF2 underscore in, which is going input to flip-flop 2, will violate the setup requirement of flip-flop 2. And the output of this flip-flop 2 will go into a metastable state. Similarly, on the next edge, here, there are two possibilities. Either this FF2 underscore in will not be sampled by flip-flop 2, or again, it will create a metastable state by violating the setup and hold window of flip-flop 2. In both the scenarios, output of flip-flop 2 will be incorrect. So this way, it's not possible to sample this FF2 in at this first edge or at the second edge, and output of this flip-flop 2 either can be metastable state or can be an incorrect state. So very easily we can say that if this particular phase difference between clock A and clock B is applied, my pulse from clock domain A cannot be transferred to clock domain B. And as we know that clock domain A and clock domain B are asynchronous to each other, any phase difference can be applied between the clock domain and clock domain B. And if I say that this particular logic will work to transfer this pulse from clock domain A to clock domain B, it should pass all the combinations. Whatever phase difference I apply, this pulse should be passed safely to the clock domain B. But I have figured out one scenario where this pulse will not be transferred and it will always fail. That is the reason I can say that this logic will not work. But friends, just for your information, for some particular phase differences between clock domain A and clock domain B, this pulse from clock domain A can be transferred to clock domain B with the help of this multi-flop synchronizer. Friends, now let us consider the second case where clock A frequency is greater than clock B frequency, and let us prove that this pulse from clock domain A cannot be transferred to clock domain B with the help of this multi-flop synchronizer. Here I have drawn a timing diagram. This is clock B. Its frequency is very less with respect to clock A frequency. As we know that we are feeding this pulse to this data signal which is input to flip-flop 1, and on the positive edge of this clock A we will get this pulse at out of this flip-flop 1, which is nothing but FF2 underscore in. So here I am displaying this pulse, And now it is very clear that flip-flop 2 is working at clock domain B. And when this pulse appeared, there was no positive edge on the clock B. So this pulse will be missed by flip-flop 2 to be sampled. If this flip-flop 2 missed this pulse to be sampled, then this pulse cannot be transferred to the flip-flop 3 and so on. Hence, we can say that in this scenario also, when clock frequency A is greater than clock frequency B, this pulse cannot be transferred from clock domain A to clock domain B with the help of this simple multi-flop synchronizer. Friends, now let us consider the third case, which is our last case where the clock frequency A is less than the clock B frequency. And let us prove that this pulse cannot be transferred from clock domain A to clock domain B with the help of this multi-flop synchronizer. Here I have taken a timing diagram, and clock domain B frequency is quite high with respect to clock domain A frequency. As we know that we are feeding this pulse onto this data input, which is input to this flip-flop 1, and as soon as there will be positive edge on the clock A, this pulse will appear at the output of this flip-flop 1, which is FF2 underscore in. So this pulse is appearing here. As soon as the positive edges will come on the flip-flop 2, it will keep on sampling the same pulse. So depending on the frequency difference between clock domain A and clock domain B, the flip-flop 2 can sample it for multiple times. So similarly, it can supply multiple pulses to flip-flop 3, and flip-flop 3 will supply multiple pulses to the next logic which is working in a clock domain B. So instead of passing one pulse from clock domain A to clock domain B, we are passing multiple pulses which are dependent on the clock frequency differences between the clock domain A and clock domain B. Friends, we have proved that this pulse cannot be transferred from clock domain A to clock domain B with the help of this simple multi-flop synchronizer. And we have considered all the possible frequency and phase differences of clock domain A and clock domain B. Friends, now I have a question for you. If it is not possible to transfer a pulse from clock domain A to clock domain B with the help of this simple multi-flop synchronizer, then what is the correct way of transferring this pulse from clock domain A to clock domain B? Those who know this answer, please write it down in the comment section and we can discuss it there. Otherwise, I will reveal its answer in the upcoming video. And with this, I am going to end this session, and I hope that this would be quite informative for all of you. If you also like this video, please press the like button and share your feedback in the comment section. And in the future also, we'll come up with very interesting topics. So to be aligned with our channel, don't forget to subscribe it and press the bell icon to get the notification of all the upcoming videos. Thank you so much for watching.